There we go. We are unmuted. Live and unmuted. I had to wait to unmute myself because there was this really, really terrible honking going on outside. It was because as soon as anyone was allowed to do anything ever again in their life, everyone started honking again. Everywhere. It's terrible. It's disgraceful. Absolutely disgraceful. Absolutely disgraceful. All right. Here we go. Some people starting to file in. Thank you. Thank you, thank you, thank you. Far too kind. Hanging out with me today, this afternoon. I hope it's not too late for anyone in Europe. I know you have very strict schedules about when you need to start drinking. I appreciate that about you. I really do. All right, I'm gonna give it a couple more minutes to let some more people get in here, but we'll get started pretty quick. I don't want anyone having to hang out longer than they have to. Right? It's no fun. Waste of time. Waste of time sitting here listening to me blather and banter on. Hello, Kapil. How are you? Always happy when there's some chat message. Then that way I know that like there are actual live people out there and not just bots. Not just bots. Because if I'm just getting watched by a bunch of bots, then I don't know. They're gonna be I think bots would finally like figure out a way to kill themselves. Like that's enough. End. They'll figure out how to quit Vim, and that'll be it. I've heard that's a funny joke. Getting rid of some stuff. So how's everyone doing today? Hey, Pinal, how's it going? What's different today? Today's stream is, well, yesterday was me working through the deck and demos for a future presentation. It was me working, like just trying to figure out what I want to do, rehearsing a little bit. Today is a presentation that is I've had done it in the books for a while that I just really like. That's about indexes. It's not quite as I don't know. It's a little bit more advanced than yesterday's stuff. It's gonna dig into some more interesting things with query tuning, not just kind of like what indexes are, you know. Not just that. Today's gonna be a little bit more advanced. I have to figure out how to follow people on Twitch. Whenever I search for people, I can't find them. It's craziness out there. Alright, let's see here. Yes, it will be an adventure. It will be an adventure of sorts. We'll see what happens. Hopefully it's an adventure free of failing demos. That one yesterday is still bothering me. I want to know when I made that change. It messed everything up. It's like, huh? What happened? What happened to you? What happened to you? You went all cuckoo on me. It's just me and Brent on Twitch. Yeah, that figures. Figures. Trying to be, I don't know, boldly go where no DBA has gone before. I don't know. If this doesn't work out, then I'll stream me being terrible at video games on Twitch, which I don't know. Maybe that would be more interesting to people. I'm not sure. I'm not sure. But I don't know. A lot of other people who are supposedly good at SQL stream things and do things. I don't know if they stream on Twitch or anywhere else, but apparently things happen. I don't know. Apparently things happen. It's crazy. It's insane. People keep wanting to learn things. Good for you. Good for you. All right, we'll give it one more minute here, and then we'll get started. I think there are just about enough people for me to say, thumbs up. Let's go. I wish I was good at more things. Like whenever I talk to people who are good at SQL Server, they always have like all these other interests that they're very much into, very good at, just profoundly talented people in many ways. And I feel like a one-trick pony a lot of the time, because I'm like, I know kind of a bit about databases. Yeah, but what do you do for fun? And I'm like, I don't know. Fun? Forget what that is. I don't know. It's like this and lifting weights. Back when gyms were allowed, I was pretty good at that too. But I don't know if that's really a talent. It's just insanity. All right, it's 10 past. We'll get going. We will start talking about one of my favorite subjects in the world. That is indexes, and the reason why I am so profoundly attracted to indexes in SQL Server is because I love being able to get performance better without having to change code. Or more importantly, not without having to change the logic of code. Whenever I have to change the logic of code, I get very nervous about getting incorrect results back because, despite the fact that every query in the world I see has no lock on it already, I'm worried about results being wrong. So I'm like, look, we're going to try this. We'll see what happens, but I don't know. It's very, very tough to write logically equivalent queries sometimes, right? When people are just like, we need to rewrite the query. And I'm like, okay, to what? like what are you going to do? What's your big plan for a rewrite? It's like a query with a few joins. Are you going to reorganize the joins? What are you going to do? What's your solution here for rewriting the query? Now, there's all sorts of domain knowledge stuff that comes in there too, right? Like you might find a query looking at someone's server and be like, this query is a piece of crap. Who wrote this? We got to fix this immediately. And they're like, oh, that should have gone away. We don't even use that module anymore. And they'll like spend a few minutes looking through source code and be like, delete it and like gone. And to me, that's like a perfectly tuned query is one that just never executes, right? It's just gone. It's never going to run. That is the fastest possible query you can ask for. But I hate making big structural rewrite changes to queries because I'm like, I don't know if I'm going to get this right. And then it's always very difficult and confusing when you're doing that, because if you get different results back, you're just like, what happened? It's very frustrating. So I love indexes because usually adding indexes, or even not just adding a net new index, sometimes just changing the way an existing index is arranged can just have such a profound impact on performance, make things a whole lot better. And that's the kind of thing that I love because I'm a consultant. and the less time I have to spend actually doing something, the more my time is worth, which is awesome. So if I can make quick index changes, or if I can identify indexes that'll help a bunch of queries, and I'm like, sweet. sweet. I don't have to, I have to do far less work. A lot of the times when I come in and start working with people, the situation will end up being something like no one has ever really looked at like SQL Server's index DMVs for anything, and I can identify like a couple few indexes from there. There's like they may not be perfect because the missing index requests aren't perfect, but they might be good enough to get a whole bunch of queries to a better place. So if I can add in like, somewhere between like, 5 and 10 indexes, and I can get like an entire workload to be better off, then I'm psyched because I don't have to go in and actually start tuning code and things. I'm very happy when I can just like adjust indexes a little bit and have like the workload overall be better. Right? Yeah, and people love that's the kind of stuff that end users are like, wow, like that has a good effect on people. Like, like working with people when they have no interest in databases. They have no interest in SQL Server, indexes, anything like that. They're just sitting there pressing a button. They're like, I just want to know why every time I press this button, I waste 30 seconds of my life. I want to know, like, if I have to press this button 10 times in a day, those 30 seconds start adding up, right? If I have to press this button 100 times in a day, forget it. I'm never going to leave work. All I want to do is press this button and not waste 30 seconds of my life. And sometimes indexes really can do that. There's, like, all those, like, like consultant, like, glamour stories, or just like, let me tell you about this one time. Sit down. Everyone sit down. There was this query. There was this report. And it ran for 48 hours. It would take all weekend. I came in, I added an index, and it finished so fast, everyone thought that the process was broken because it finished so fast. And you're like, wow, cool, what was the index? And it's just like the most boring index in the world. But that's how good they are. That's how much indexes really do help things. That's how like important indexes are to a workload. When I talk about indexes and databases, you do have to spend some time getting like the right amount in there, because indexes to databases are a lot like salt to food, right? You want to make sure that you have enough salt in there that you can taste it, but not so much that you end up like pre-hypertensive, right? Because that's not a good look either, right? Just getting sweaty and out of breath constantly is not a good look for databases. So they are in the same way. It's very easy to tell when you look at a database if there is too much or too little salt in there, because just the same way when you take a bite of food and it's just like this doesn't taste like anything, or if you take a bite of food and you're like I just had a heart attack thinking about it. It's wonderful. Wonderful. Wes says, I'm so glad that I don't know the data model for the databases I manage. I get to look at the indexes and not the bad queries that the reporting team writes. Yeah, absolutely. Like the less you know, but the big, like if you know nothing and you can still have a big impact, that's awesome, because you can spend like the rest of your brain, like rest of your brain space on more important things, right? Just like, I don't know, people's birthdays. like non-SQL Jeopardy facts. It's great. It's great to have. So anyway, let's go and we're gonna. So the way this talk is set up, we're gonna start on the easy side, and we're gonna work in, and things are gonna get a little bit more challenging as we go along, and we're gonna solve tougher problems as we move along in this. Right. So we're gonna start off with like some some basic stuff, just to make sure that everyone kind of understands where we're at, and then we'll get on to harder stuff. So don't worry if you feel like the first demo is not really like the most advanced thing you've ever seen in the world. You're right, it's not. It's just kind of a warm-up, just to make sure that we're all cool here. So let's get going. And let's talk about how indexes can give SQL Server better choices for how we join tables together. Right? So let me actually just go back up here. Let me make sure that we are starting from fresh, because I don't want to start from not fresh. Because if I start from not fresh, then demos are going to get confusing when I run them. So what we have here is a pretty simple query. It's just one join in there, and just one part of the where clause. We're going to join a table called posts to a table called users. Users make posts, and based on how good posts users make, they get higher reputations. If you know anything about Stack Overflow, Stack Exchange, if you post questions and answers on there, you'll know that it's really, really hard to get a high reputation. Like, you have to really post a lot in order to get a lot of upvotes, or you have to have like really good posts to get a lot of upvotes rather. So it's not an easy task to have a reputation over 100,000. If I stick a comment in there, that is the right number. That very rarely happens to me. I'm very proud of myself for that. So what we're going to do is we're going to get a count from this join, just for how many posts do users with a reputation over 100,000 have. And that's not a whole lot of people, but This query is a little weird. This query takes a little bit longer than I would want. And if we go look at the execution plan, we go look at the details, we can zoom in a little bit here. Let's look at what happened. Well, we started off with a scan of the users table, and this didn't take long at all. This was pretty quick. Right? We scan the users table, we get the 613 rows that we care about, right? Again, not a lot of people have a reputation over 100,000. If we go and highlight over this arrow, and I will zoom in. Actually, do I have to kill that? I don't see. This is crazy. I don't remember if I restarted my computer yesterday. That's how much of a goldfish I am. And I didn't know if I still had Zoom it running, which it doesn't look like I do. So I should be able to just zoom inside of this VM for free. So if we look at this, SQL Server did a pretty good chunk of reads here, right? We didn't pass on all the rows, but we had to read about 2.4 million rows just to get 613 out of there. But this was fast. This was fast. This was okay, right? At 47 milliseconds, even if I created a great index there, this wouldn't fix the overall performance of the query, right? Because this query if we go over here and we look at how long it took, we can see that it took about 1.86 seconds. If I cut 47 milliseconds out of that, I'm no hero, right? This is not where the index kicks in and it's just like, you did it. No, that's not where it is. Where it is down over here. And I love new versions of SQL Server and Management Studio where we start to get this kind of feedback back from execution plans. Otherwise, people just, they get all caught up in costs and just weird metrics, and they're like, oh, we got to fix this. But the real root problems become much, much more obvious when you have these operator times in there. These operator times, if you're new to this stuff, is just these numbers here that come up under the operators in newer versions of SQL Server when you go ahead and get the actual execution plan. So all these things. Now, a couple little differences here. If it's a query that only has row mode operators in it, remember there's this batch mode thing that happens with column store and sometimes on SQL Server 2019, the times are going to accumulate going from right to left. So if we look across here, this was 47 milliseconds. This didn't take any time. This didn't take any time. And then if we look down here, that was 1.78, 1.78, and then we spent we didn't spend another 1.8 seconds here. It was the 1.8 minus the 1.778 down here. So the times accumulate going from right to left. So that's the way this thing kind of works. There is some weirdness with it, and it's not totally perfect, but for the most part, that's the behavior you can count on. So this takes 1.8 seconds, and we can see looking at this that a lot of the time was spent in this clustered index scan on posts, right? And that we have this here because we don't have an index on the column in the post table that we're joining to. This, I know, is rudimentary stuff, but let's think a little bit more about why there's a hash join here. Right, because really the root of it is not exactly the that there's a scan over here. The root of it is kind of why a hash join? Why SQL Server would you choose to hash this? Well, think about the SQL Server's two alternatives. The other types of joins that we can have that we could have is a merge join, right? So if I run this and we look at what happens when we tell SQL Server to give us a merge join, oops, I got a little excited there. We're telling SQL Server, give me a merge join here. Remember, the other query finished in 1.8 seconds. With a merge join, we finish in 5.7 seconds, right? So that's not an improvement. SQL Server was right about that merge join. A key difference in the execution plans if SQL Server chooses a merge join is it needs sorted input going into the join. I kind of messed up on the zoom there. There we go. That's what I wanted. So this merge join over here is going to expect sorted input from both sides. The users table is already in a useful order for us because it's on the ID column that we're joining from the users table is indexed. It's a primary key. It's a clustered index. So we have that data in order. We don't have the owner user ID column in order, so SQL Server has to sort it. And prior to sorting it, SQL Server is like, well, if I have to sort all these duplicate values, the first thing I'm going to do is aggregate them down to the smallest possible list I can. This adds a bunch of overhead, and we actually end up spilling out to disk a little bit. I'm not saying the spills here are the cause of the performance problem, but you can see that SQL Server had to do extra work to implement a merge join here. The other option would be a loop join. And loop joins really make the most sense when you have both sides of a join indexed on the join column, like with the join columns in the index somewhere. Kind of depends on what your where clause might be up to, but let's just say that your join column should be indexed at some point. If we look at what a loop join does, it's not really any prettier than the merge join or the hash join, right? Like this is kind of bad news. This is taking a while too. This took 9 seconds. What's up, Lee? How's it going? So this took a while too. And if we look at what happened here, this is about what we expected. But then SQL Server starts picking up a whole bunch of steam on here, and then things just don't go so well. So SQL Server, in order to do a merge join or a loop join, would have to do a lot of extra work, a lot more work than we'd have to do with the hash join. Right? The hash join actually turns out pretty well comparatively. But the hash join does require a scan on both sides, and it's a lot of work, I think, because going back to this a little bit, it's a lot of work for a join that we know is only going to produce 613 rows here. So if we want to give SQL Server more choices, if we want to give SQL Server easier choices about using different kinds of joins, then we need to make sure that the columns that we need to relate from one table to another have indexes on them. And again, I know this is pretty rudimentary stuff, very smart people out there, but everyone has to start somewhere. And so if there's anyone in there who maybe is not the absolute hasn't been tuning queries and indexes for a while, and just needs a little sort of basic guidance on this stuff, usually you want to have your join columns indexed. And once we add an index, and this is, again, very simple index, just because our query is very simple, this isn't the kind of index that I would go and create in real life, because it's just a single column non-clustered index. That's not going to be helpful to a ton of queries. But for this demo, with this index in place, if I just have that index right there on owner user ID, SQL Server all of a sudden has lots of choices, and lots of cheaper choices for coming up with the join that it wants. So now not only do we have a much faster query, with this thing taking 343 milliseconds rather than 1.8 seconds, or 6 seconds or 10 seconds without the index and the other join types, this ends up much better. We still scan the clustered index of the users table, but now we're able to use a nested loops join, and we're able to go and seek into the post table for just the 613 rows that we care about that come out of the users table. Remember that even though the users table is pretty big at around 2.4 million rows, there are only 613 rows coming out of this that we care about. That makes it very easy for SQL Server to say, I have 613 of these. Yes, I am going to seek 613 times, but boy, is it going to be a lot faster than 1.8 seconds. Are there any questions on the joins part before we move on? It's totally fine if there's not. I'll give you a couple seconds to say something, just because I know there's a little bit of lag here, and I don't want to get started and then have a great question come up to go back, because boy, is that embarrassing. Boy, would that be embarrassing. Be sad, right? Sad. I would be sad. I would be sad if I had to do that. All right. So indexing join columns, pretty normal thing to want to do. Without the index, really hash was the only sensible join strategy. Merge would have to sort and aggregate, and then nested loops would also have to do some pretty ugly stuff with the sorting and aggregating too, because there's really no other way to get those joins to be fast without doing that work. And especially for merge, where you need that sorted input, not having an index there just really makes it suck. Actually, I should show you the difference when I force the merge join with an index on owner user ID. This here will be a lot better choice too. It's not going to be the fastest thing in the world, but if you remember the other query plan, notice that we no longer have to sort any data coming out of the post table. We have the data in the order that we want it in, right? So we don't have to hash that data, and we don't have to sort that data, but we do still choose to aggregate that data just to make the join a little bit more efficient. All right, cool. So let's move on to the next bit. The next thing is one of my absolute favorite demos in the world, because it deals with one of my least favorite query plan operators in the world, and that is an eager index spool. And rather than try to talk to you about it first. I'd much rather just talk through exactly what an eager index spool is and what it does. So let's clear out our old indexes because we don't need these anymore. And what I want to do is run this query with a top 38 here. All right, so I'm going to get the top 38 rows from users, and I'm going to cross apply to badges to get everyone's most recent badge. Right, so I'm getting the top one, name from badges, correlated on user ID, and ordered by date descending. So I'm going to run this query with a top 38, and this isn't going to be too bad. It's not spectacular. It's not spectacular, but it is not too bad comparatively. So just memorize the shape of the plan. Memorize the shape of the plan a little bit. We don't need to memorize the entire plan. We don't need to make a big fuss out of what exactly happened. But notice that we have the users table, we have a sort, we have a loop join, we have a sort down here, and we have a clustered index scan down here too. All right, so just the sort of general shape. We scan users, we sort it, we go into a loop join, and we sort stuff coming out of the badges table too. Pretty nice, pretty simple. Now let's look at what happens when we bump that up to a top 39. When we bump this up to a top 39, things are going to slow down pretty considerably. And while things are slow, let's chat a little bit. Let's see. Stefano says, "Nice ASCII art, thank you." Oh, you know what? I'm going to put a link to where I make all my ASCII arts into chat, so that if any of you want to also ASCII up your presentations or whatever, you can do that. Let's see here. Lee says, "My nemesis of late." Lee, if eager index spools are your nemesis of late, you have a very easy job. Because those are problems you can solve real quick. Hi, David. Nice to have you here. Yeah, great to catch you live, too. Beats the alternatives, right? Anyway, so this took 22 seconds. 22 full seconds. All right, 21.884 seconds. But you know what? This is horseshoes. This is hand grenades. This is close enough to 22 for me. I'm not going to split too many hairs here. Now, we're going to go back to using our old friend operator times, and we're going to remember that reading the query from right to left, operator times aggregate from operator to operator. So we can see that this part here was quick, right? This was not slow. And we can even see that this clustered index scan on badges was not slow. That took about a second. What took a long time here, what took 21.829 seconds, was building this eager index spool. Now, eager index spools are interesting for a couple reasons. One, they represent SQL Server calling you a very lazy person. They're a very passive-aggressive operator because SQL Server has chosen to make an index for us while the query ran. SQL Server has chosen to take the entire badges table, spool the columns that we care about to TempDB into what's effectively a temp table with a clustered index on it. But it gets more interesting. It gets a little bit more interesting because if we get the properties, now one of the most important things in the world, one thing that I cannot stress enough to you about how important it is, always get the properties of these different operators. If we get the properties of the clustered index scan, even though SQL Server is telling us that this went parallel, we have our little parallelism badge, we have our little racing stripes there. Even though SQL Server is telling us that this went parallel, all 8 million rows are going to end up on a single thread. They might, like which thread they end up on might change, but the fact that that the table gets read single threaded to create the index is always true. This is 8 million rows, and this takes 21 seconds. So really the big thing here is that even in a parallel plan, this scan before an eager index spool is going to be single threaded. And that's just kind of bad news. Now, I used to think that this was Microsoft really just kind of enforcing a weird limit, because when you create indexes in Enterprise Edition or Developer Edition, what do you get? You can get parallel index builds, right? Good stuff. Standard Edition, you don't get that. So I thought this was Microsoft being Standard Edition people, you get nothing like that. But it actually turns out, but I talked to a very, very smart person at Microsoft who told me that there was a very, very high likelihood of deadlocks if we build indexes in parallel on the inner side or within an eager index spool. So apparently there's a good reason for it, but who who am I to judge? Now, we can read from the index spool in parallel. If we look at what happens here, it is maybe not the prettiest, most even spread in the world, but it's not terrible. This isn't the end of the world here. So we can read from the index spool in parallel, but when we bring data into the index spool, that's going to be single-threaded. The good news, sort of, is that there is a weight type that gets associated with this. If you have a parallel plan like this and an eager index spool gets built, again, this is why it's always important to go looking at the properties. In the properties on newer versions of SQL Server, we can see the weight stats that a query generated while it ran. Well, not all of them, not all of the good and important ones, but we can see a pretty good chunk of them. And if we look at weight stats that got generated for this query, we can see like some pretty normal ones that we might usually see on a SQL Server: SOS scheduler yield, memory allocation, CX packet. But then we have this sort of oddball one down here. This oddball one down here is called exec sync. Now, there are other things in SQL Server that can cause exec sync weights to happen, but normally, when I go and look at a server, and I, use, it doesn't matter if it's Paul Randall script, if it's SP Blitz First, whatever weight stat script you like. If I see exec sync weights on a server that are, fairly high, and especially if they have a long average duration, like if you look at this one, this weight actually generated 65 seconds of wait time, because remember, it's generating in parallel. There are multiple threads waiting on that eager index spool to get built. This is a .4 query, so there are four threads waiting on that. So we have this exec sync wait coming up. If I see this is a pretty long wait on average. If I had this query running a lot, it would always be waiting 20 seconds on the index spool to get built, because remember, they get thrown away as soon as the query's done. SQL Server doesn't keep them around for anything. But if we have this exec sync wait and we see that it has a pretty long average duration, then I might be paying special attention looking at poorly performing queries for eager index spools. Now, if this plan was serial, if this was a single-threaded plan, we wouldn't have a weight that was helpful to us. But in parallel plans, that thing shows up and is a pretty good red flag about what might be going on. Now, if we want to fix eager index spools, we can't count on help from SQL Server. There's no missing index request here. There's no SQL Server, SQL Server is not sitting there saying, ooh, green text, we need help. Danger, Will Robinson. There's nothing there. And it's not like this is just SSMS being broken. There's no missing index in the XML either. I'm not going to spend a lot of time scrolling through that, but you get the point. SQL Server isn't telling us that it needs an index. SQL Server is just hauling off and building this index, and it'll do it every time the query runs. It'll toss out the result, the index data later. It's up to us to look at what's going on and kind of figure out a good index. Now, the easiest way to do it, if you don't want to spend any time on it, if you look at the eager index spool, right, and I'll zoom in here, there are going to be a couple different parts of the eager index spool. Well, one part is optional, one part is always going to be there. The part that's always going to be there is going to be a seek predicate. And you can think of the seek predicate as sort of like what the key of the index would be. Would the sort indicate help? I'll cover that in a second. So the seek predicate here is going to be what SQL Server built the key of the index on. Now, SQL Server, of course, when it creates an eager index spool, the object up in TempDB is pretty much like a temp table with a clustered index on it. We already have a clustered index, so we would have to build a non-clustered index to satisfy this query. But we don't, right now on the badges table, we don't have an index on this user ID column. And the user ID column is what SQL Server wants the key of the index on. We also have two other columns involved here. We have the name column and we have the date column. Because remember, what we're doing is selecting the name of the badge for a user ordered by date descending. So we're getting their most recent badge. So we have three columns that we would need in an index in order to make this thing go away. So if you wanted to do the easiest, most basic thing in the world, it would be to look at this tooltip, create an index with a key column on user ID, and then create or then add name and date as included columns. That would be very easy. But remember something. Remember what the query looks like. We're ordering by date descending. So what we might want to do And this is only something that you can do if you look at the query and you look at the execution plan. What we might want to do is also have date as a key column so that we can have the date column in order for free when this runs. And I'll show you what I mean. We don't need to have the date column first in the index. We need to have user ID first in the index, because that's going to be what we seek to. And then what we're going to have next is the date column. This doesn't even have to be descending, what I'm going to show you. But then we'll have name included here. So what I'm going to do is create this index. And the nice thing about creating this index is that it doesn't take 21 seconds to create, does it? It doesn't take 21.8 something seconds. No, creating this index, nice, fast, in parallel, takes 1.7 seconds. What the hell was SQL Server doing for another 20 seconds when it created it on its own? I don't know. Apparently, there's a whole bunch of stuff about spools that just didn't get the message about certain optimizations that the rest of SQL Server did. I'm not going to get into it here because, we only have so much time. But this is they kind of fell behind a little bit. When we have the no child left behind thing in America, we should have the no operator left behind thing, because some of these operators were left very far behind. So now that we have this index on user ID, date, and include name, if we run this query asking for the top 39, we're not going to have that index spool anymore. SQL Server already has data, or has the data that it wants in the right order, right? So when we seek into the badges table, this takes nothing. And when we look at the top, right, again, we don't need to sort. This isn't a top and sort, it's just a regular sort. The only sort that's happening is actually on the user side, kind of shockingly. Kind of shocking. I don't know why it's shocking, but it's kind of shocking. It's a little shocking. Up here we have to order by reputation descending, because that's what we're doing there. Right, so it's no funny tricks. That's ordering by reputation. But now this finishes a lot faster. And now this is actually something that I was trying very hard to write a demo to do yesterday, but now I have one magically today. SQL Server. Now we have a missing index request, right? When this query took 22 seconds and we were building an index while the query ran, no missing index request. Now that we have this query down to under 200 milliseconds, SQL Server is oh, I got it. I got the solution. I know how to fix it. I can do it. It asks for an index on the reputation column on the users table. It says, give me an index on reputation and include display name. What is that going to fix? Cool, it'll take off, I don't know what, 100 milliseconds, 85 milliseconds? We already did all the work. Screw you, SQL Server. Why are you chiming in now with this nonsense? So whenever you see eager index spools and execution plans, they are a giant red flag that there is some very obvious index for this query that does not exist on the table currently, and that remember, always use as much feedback as you can before you go and make these changes. For this query, it was very, very obvious that we needed an index because it was taking 22 seconds, and most of that 22 seconds was spent building the eager index spool. If you see eager index spools in plans and you're able to get the actual operator times, but the eager index spools aren't the thing that's taking a long time to build, they're not really the reason why the execution plan is slow, then it might not be worth it to fix them. But in general, when you see eager index spools and plans, that is something that you should focus on at some point in your investigation, because I guarantee you that there's an index in there that could help, especially if you're dealing with a long-running query, and especially if the table that the eager index spool is being built from is a rather large table. I think that's probably the best rule of thumb. Think about the size of the table that that's being fed into the eager index spool, and if that's a big table, then that's probably something that you're going to want to fix, because the bigger a table that feeds into an eager index spool is, the longer building that eager index spool is going to take. So it doesn't look like there's any questions, so I'm going to move on, and we're going to talk about a slightly different kind of spool. Of course, if you have any questions, just chime in chat. I'll backtrack and answer them. But for now, I'm going to move on, and we're going to talk about table spools. Table spools are sort of like index spools, except that they don't have any index on them. They're just sort of where an index spool is sort of like a temp table with an index on it. Table spools are like a temp table with no index on it. They get used for different reasons. But again, implementation details are kind of boring to get into. But table spools, they happen for different reasons, and they sort of have a different sort of have a different usage pattern. Now I'm gonna create these two indexes, and while they create, I'm gonna talk a little bit about the query, and I'm gonna talk a little bit about why the last query for eager index spools and this query for table spools have some things in common. Now, one of my absolute heroes in SQL Server is a guy named Adam Mechanic, and I used to always see him writing cross-apply queries, and I said, man, those cross-apply queries are awesome. I get to write cross-apply queries. And when I started doing that, I started running into very Adam Mechanic-y problems. I started understanding the things that he would talk about more and more. And like whenever I would see him talk, I was like, oh, that makes total sense now. Thank you, Adam. But this is a cool one. So the reason that cross apply tends to work well for demos that have spools in them is because cross apply is just about always optimized as a nested loops join. Whenever you have a nested loops join, you have a loop. And whenever you have a loop, you have something that is going to happen repetitively. That is what a loop is. You have the part of the query that's like, you have what's called the outer side of the loop, right? Which is up here. And then that is, kind of like the thing that happens once and feeds into the loop. Then you have the inner side of the loop. And the inner side of the loop is a thing that needs to happen over and over again. Spools usually happen because SQL Server wants to do something less repetitively. If we think about the last query that we ran, that where the tipping point between 38 and 39 rows in the top, at 39 rows, SQL Server said, I don't feel like scanning the badges table a 39th time. I'm going to build an index once, and I'm going to use that index 39 times. For this query, you're going to see something kind of similar. You're going to see SQL Server use it, like we're going to have a nested loops join because of the cross apply, and SQL Server is going to try to cut down on repetitive work by using a spool to only get new data sometimes. And I'll explain to you exactly what that means when we look at the execution plan. Ronald says, do you ever use live execution plans? Occasionally I'll use live execution plans, only if I am completely dissatisfied with how long I've been waiting for a query. I might kill it and use a live execution plan to see where things are getting gummed up. But a lot of the times, if you turn on actual execution plans and you use like SP Blitz Who or SP Who is active, they'll give you a snapshot of the live execution plan so you can kind of see where things are at anyway. Live execution plans are totally fun to watch, just sort of like, as trivia, but they're not something that I rely on for query tuning regularly. So what we're going to do here is we're going to stick some data into this temp table. And this temp table doesn't have any indexes on it. It's just a single column. And what we're going to do is we're going to stick in user IDs for anyone who has this badge called popular question. The thing about this badge is that you can get this badge many times. And we'll look at that in a second. But now let's run a query that takes data from the temp table, and we do some work to figure out like the most popular question by score that someone asked who had a popular question, right? So it's a pretty, kind of a useful query, right? So we take people who have this popular question badge, and then we do some work to figure out what their most popular questions are, right? So it's a pretty good thing to do. We say, okay, you have a lot of this badge. What do you got? What's in there, sport? What do you got going on? What's so great about you? This will run for about 11 seconds. All right. So again, 10.8, it's close enough for me. It's close enough to 11 for me. I'm not gonna, again, horseshoes, hand grenades, and 8. I'm gonna round up a little bit. And again, backtracking, reading execution plans from right to left, or at least looking at the operator times from right to left, we can see that we build up a lot here, right? And we spend a lot of time in here. Remember, this is 1.126 seconds, and this is 7.429 seconds. So like the majority of the query time is spent here. Now, we talked about eager index spools last time. Lazy table spools are a tad different. And they're a tad different because where eager index spools, or rather where eager spools in general are different from lazy spools, is eager index spools will read the entire result set into the spool like at the get-go. Lazy spools are different because they only go and get data when something changes. and I'll show you how you can look at that. Whenever you look at the properties, and again, always be looking at properties. A, B, C, always be looking at properties. If you look at the properties of a table spool, which is especially helpful in actual execution plans, we'll have these two things here. We'll have rebinds and rewinds. The thread spread on them isn't really the most important thing. What's important is understanding what they mean. So if we have a rebind, that means that we reused data inside of this spool. We went and got data from all the way over here. We populated the spool with it, and then we reuse data in that spool. When we have a rewind, that means, oh, I'm sorry, I have that backwards. When we have a rewind, when we have a rewind, that means that we reused data inside of the spool. You can think of that like a cache hit. When we have a rebind, that means that we went and got new data and put it in the spool. You can think of that sort of like a cache miss. Lee says, I noticed the estimates are out of whack. That's connected to the table spool too, right? I haven't really looked at that so much, but yeah, generally, since the table spool is an operator that executes multiple times, I think when you get into situations like that, it becomes more difficult to sort of forecast exactly how many rows are going to happen from one to the other. So SQL Server might make like a best effort estimate based on the distribution of values that it comes up with when it looks at the histogram for the temp table. So yeah, generally it's going to be connected to the spool, but it's a very difficult thing to figure out for the optimizer, and it's like I wouldn't focus on necessarily the estimates being way off for it. I would more focus on why the spool is happening in the first place. So we can see that this spool is doing a fair amount of work. So every time we need to rebind, we had to rebind 109,000 times. We needed to take the data that was in the spool, truncate it, and then rerun all of these operators to fill it back up. This happens because there are a bunch of duplicate values in the temp table. SQL Server, let's just say that this had the numbers 1 through 10, and the numbers 1 through 10 each happened 10 times. So we had 10 ones, 10 twos, right on down to 10 tens. SQL Server takes let's just say that the first ID that comes out of here is the number 1. So SQL Server says, I'm going to scan you. I have the numbers 1 through 10, and I have them 10 times. I'm going to put them in order, so I have my I have my 10 ones in a row, my 10 twos in a row, and so on. Then we go into this nested loops join. SQL Server says, I have a 1. Table spool, what's in you? The table spool says, I'm empty. The SQL Server says, go get all the values for ID 1. The table spool executes, goes and does all this stuff, and it brings back all the data for ID 1. And then for the next 9 times that the nested loops join takes the number 1, from the sort, it'll just reuse data inside of the spool. So it'll hit this spool 10 times in total. Then the number 2 will come along. The nested loops join will say, I have a 2. Index spool or table spool, what do you have? And the table spool will say, I have all the values for 1. And SQL Server will say, nope, go back and get me all the 2s. And then SQL Server will come over here, get all the 2s, come back, repopulate the spool with all the 2s, and then the data in the spool for the 2s will all get reused 9 more times. So that's why spools like this exist. The thing is, there is almost no reason for us to have duplicates coming in here, because the purpose of the query is to just get a sum of scores for people based on their high scores, right? We don't need to look at a single user's high scores over and over again. Now, if we look at what's actually in the temp table, so we're going to look at what got in there. We're going to look at user IDs and how many exist, and then we're going to look at a count of distinct records overall. We'll see that for the number of records that are in there, or the number of user IDs that we have in there versus the number of distinct records that are in there. It's like a lot of the reason that we have 368,000 rows, because we have hundreds of entries for other user IDs, right? And that's not something we don't need to know the sum for user ID 4653 623 times. You just don't need that. It's just not going to do anything for us. So what we can do is, rather than put all that additional data in there, is we can stick a primary key on our temp table, and we can only select distinct user IDs into it, and we'll end up with far fewer rows in the table overall. right? So I've dropped that old temp table, I put new data in it, and now when we run this query, it's maybe not going to be the fastest thing in the world. Like there's probably still some index tuning that we could do, but I think 3 seconds is a lot better than 11 seconds, and that's 3.3 versus 10.8. And if we go and look on the, drag that over there, bring that plan back. If we go look, there is no lazy table spool on the inner side of the nested loops. SQL Server just goes over here, scans the clustered index, and we do a very simple loop, and we just get the rows that we need. So while the spool does help us with not doing repetitive work between, the theoretical here and here, we do have to touch that data inside of the spool over and over and over again, which is kind of a bummer. So with just like, not even sticking a different index on the post table, just sticking the right index on the temp table, we can have a much better query. We don't have to use that spool. We don't have all those duplicative values in there. We can solve a lot of problems. If there are any questions on this, go ahead and stick them into chat. I'm gonna move on, but at the same time, if you have questions, I don't mind backtracking a little bit. It's always a pleasure to answer questions. So now let's talk a little bit about how indexes can help solve blocking problems. Right. So if we again clear out our indexes here, and what I'm going to do is run this update here. Now I'm going to use begin tran to exacerbate things. I know that begin tran isn't like begin tran and waiting a while isn't the most realistic thing that you might see in production. Maybe it is. If it is, I'd love to come help you out. There's a contact form on my website. We could chat about that. I'd love to help you with that. But let's just say that this was a long-running update for other reasons. So we're going to run this update with the begin tran, and we're going to come over here, and we're going to try to run 2 queries. Right? We're already using the right database. If I run this query finishes instantly. Right? Good stuff there. So we have this data back. This query was not blocked. If we run this query, though, this query will start taking a suspiciously long time. This query will not finish instantly. This thing is still down here spinning away. If we go and look at SP who is active, we can get some interesting information about what locks got taken here. Again, well, first off, we can see that this query has been blocked for about 9 seconds, and it's still going. It's like because that begin tran is open, this thing is just going to sit around waiting all day long. And I know this is exactly why people use no lock. Who the hell has time for this? But if we go and examine things a little bit, come over here. The query plans really aren't all that important here, but what is sort of important are the locks that get taken. So right now, SQL Server has taken an intent exclusive lock on the object, which if you were here yesterday, you know that this does not mean that the object is locked. This just means that we can... Oh, hello, party time. This just means that SQL Server has taken an intent exclusive lock at the object level so that it can lock things at a more granular level. David says, is there anywhere we can grab the SQL that you use in your streams? Sometimes this stuff... Not really. If you have the Stack Overflow 2013 database, it might be interesting, but a lot of the times people don't have that and don't feel like getting it. If you really want it, I can publish it somewhere, but a lot of people just don't. Like, I have bit.ly links to this stuff, and I look at the download from them, like before and after I give presentations, and they hardly go anywhere. You too. So, if you really want them, I can give you a link to them. But, so we see here is that SQL Server did take some page locks, and those are exclusive locks. Right? So that did happen, and we can see that there are 9 of them. So we just got very unlucky that the ID that we wanted, 1317729, was just happened to be on a page that was blocked by that update. If we go and run SP who is active again, we can see that, I don't want to figure out what that number is, but it's a long number. So let's kill this off, and let's think a little bit about what's happening. All right, we should probably roll this back before we go and do anything else, right? So what we have is an update against the badges table. Now, if I run this and I just get the query plan for it, we can see pretty simply that this thing has scanned the entire badges table, and then we have to update the badges table based on that. So what we'll see is that this thing we have to scan the badges table. And now something kind of quirky. Now this isn't, I want you to understand that this is not like an always and forever, like pinky swear sort of rule in SQL Server. But sort of generally, if you have a modification query and you start with a scan, you're going to have you're going to start with page locks. If you have a modification query and you start with a seek, you are most likely going to start taking row or key locks, right? They're the same thing, but some people call them row locks, some people call them key locks. There's not a lot of other terminology out there for pages. That's sort of a general rule. It's not a perfect rule, but it's something that you can keep in mind. If you see a scan where the data is coming from in a modification query before you come over to the right, you're most likely going to start taking page locks. Either one of them might escalate to an object lock, right? You might go from like the row/key lock to an object, or a page lock to an object. You don't go from row to page, keep in mind. That doesn't happen. But if you go from you can go from like the row or key locks up to object, or the page locks up to object. So in this case, we didn't escalate locks. The entire object wasn't locked. That row just happened to be on a page that got locked because SQL Server said, I don't really know where this data is. I don't really have a good way to find this data, even though I'm searching by ID. Like SQL Server is like, I don't know where to find these dates. These dates could be anywhere. But with a good index on the date column, what we'll do is create that. So now SQL Server has a very good way to find dates. And since we're updating user ID, we're not updating the date column, we can begin tran over here. And when we run these two queries now, they both finish instantly. The difference, of course, is the type of locks that SQL Server took when this thing was rolling along. Now, if we go look at the locks column, things will be a little bit different. We'll see intent, again, we'll see the intent exclusive locks on pages, and we'll see the intent exclusive lock on the object, but the only thing that actually gets exclusive locks, that only gets this X, are the keys of the primary key, right? So only key columns. There were 1,447 of them, which is more than the page locks that we got, but that's okay because it finished really quickly, and if we weren't being knuckleheads and doing a begin tran, then we wouldn't have a problem. And if we go look at the execution plan, now we'll see that we have done a seek into that index to find the right dates. And because, again, general rule of thumb, like there's a lot of sort of like nice sort of cloudy stuff around this, because we started with a seek, we most likely started taking row/key locks rather than taking page locks. So that's a nice thing to do there. So always, whenever you're trying to solve locking problems, one thing that I always want people to be looking at is their modification queries. If those modification queries have a join or a where clause, there's a very, very good chance that we are just missing an index to help those queries find data. David says, I always use a Stack Overflow database when following Brent streams. Yeah, so just to make sure that you understand, this is Stack Overflow 2013. This is not the full-size Stack Overflow database. So these might not translate totally fully over to you, but if you have 2013, then they should work pretty well. Yeah, so let's see. Mr. Shah says, so is proper indexing the correct answer to what I should use instead of no lock? It depends a bit on the situation. Proper indexing is generally a very good place to start for these things. Another thing to consider is that you might just have modification queries that are just doing too much at once. And what I mean by that is if you have a modification query that even if it has a perfect index so it can find the data it needs, if it's updating like tens of thousands or 20s of thousands or millions of rows, that thing is always going to try to escalate, and there's always going to be blocking. Kind of like the more stuff you have to change in one go, the longer that query is going to take. A friend of mine, he's Canadian. Don't hold it against him too much. He's nice. Let me get the URL. But he wrote a wonderful blog post about scripting batches to to reduce the amount of locking, be nicer to transaction logs, not have like that specter of lock escalation popping at you. So this is a very good blog post about that. I would say generally when I'm trying to solve blocking problems, one of the first things I'm going to do is I'm going to figure out if the database is a good fit for an optimistic isolation level, like read committed snapshot isolation, or if I just need to target specific queries and maybe snapshot isolation. Second might be trying to figure out if my modification queries could use an index to help them find data. Third might be, okay, how many rows are we typically modifying? Should we rewrite this process to batch the modification query so that we're not taking like as excessive locks for as long? And then after that, I would be totally cool with you using no lock hints because you have exhausted all your sort of sane and rational options. So there is that. Chris says, I'd also love to have the database. Well, if you want the database, you can go. Let's see. I know I have that somewhere. Give me a minute. If you want the database. Why are you asking me to log in? Oh, you knucklehead. I forget how I log in here. There we go. All right, give me a second. Let me grab. I have to warn you, it's not going to be a fast download because it is a decent sized database. So let me copy this link. And let me come back over to chat. So if you want the database, you can go there. And I think I have. Oh, that's an old version though. Yeah, I have an older version. I have a link to an older version of this in Bitly. Let me see if there's a newer one. Because then I might be able to just throw you the scripts. Real easy. You know what? I can't find it quickly, so I'm going to move on. But yeah, if you want to grab the database, it's right there. If you want the scripts, I'll put it out on Twitter or something when I'm done. Or I don't know. If I can add a link to like the data, like the description of this thing, I'll do it there. But anyway, let's move on from this and let's talk about something else that indexes can help with. Now, this is where problems start getting a little bit more difficult. This is where problems admittedly start getting into like the oh crap, the server's broken type of problems. Like these are like not just like, oh, I have a locking problem. Oh, the query's slow. Oh, we could fix this. Oh, this is this, that, or the other thing. This is where things really start to hit the fan. This is when like you start getting alerts about like red alerts from your monitoring tool. Users start calling you. There's all sorts of like your big important line of business application is down. People are like, I can't connect. Like nothing will run. These are the kind of problems you can sometimes run into. So what I'm going to do. Let's see here. Oh, there's a question. In my environment, application takes row locks and another update query needs that row, so there is always blocking. Is it solvable by indexes? If you need the row, then no. So if you have an update query that's locking, let's say ID 1, and another query comes along and needs ID 1, then no, that's not solvable by indexes. That's only correctly solvable by using an optimistic isolation level, either read committed snapshot isolation or snapshot isolation. Those are two kind of big areas. They're big topics to talk about, so I couldn't do them right by talking about them here because it's a very, very big topic, but that would be what you would want to do. It's better than no lock. They're better than no lock because what you get back is the previously committed versions of values in that row. So those values were correct at some point. You don't subject your application to the if it's not a word, it's a word now, to the potentiality of dirty data. So you skip over like the phantom reads, stuff you might see like if a transaction is currently in flight. That's kind of the better way to go there. If you start falling into using read uncommitted or no lock, which are effectively do the same thing. No lock is a terrible word for the hint. No lock really should be no respect, because what it does is no lock doesn't mean that you don't take locks. No lock means that you don't respect locks taken by other queries. So whenever you have a write query that takes out locks and says, I need to modify this data, please don't read it because I don't know what it's going to look like. The read query is just like, whatever, pal, I want it. I'm going to take it. So Yeah, it is. I think drop indexes is the very fast store procedure. It sets a record. But yeah, so if you want to, if you have a problem where you truly have modification queries that are touching the row they need, but another query needs that row, your only really good valid option is going to be an optimistic isolation level. All right, so let's look at how indexes can affect memory. We don't need these windows open anymore, so I'll clean those up a little bit. Nothing in there would let's see. John, wouldn't it be possible that problem row lock queries are tunable if they have poor plans? No, because the problem that he's having, or that they are having, is that the row that another query needs is locked specifically, right? So if you have an update that's taking row locks and another query needs to read those rows, it doesn't matter if your other query has a good plan or a bad plan. It matters that the rows that you actually need are locked. And if you need rows that are locked, your really only valid option is to use an optimistic isolation level. Sure, you could tune if you have a very, very bad plan for those modification queries and they're taking longer than they should, you could tune those queries to be faster, but that infers that the queries are bad, that they're taking longer than they should, and that the modification queries that are going in and taking those locks aren't taking them and holding onto them for a reason. There's a lot of processes that people have written into databases that rely on locks like that to set up a proper queuing of things, and it's not always possible to say, oh, if we just tune this query to be faster, or release this lock earlier, we can resolve blocking problems. Because a lot of the time, when people write things that specifically take row locks and they need to modify this row, but something else needs to work with it, that's always like almost every time I've seen that, it's been some weird queue that someone has written into the database. Yes, no, I understand. If it's locking them for too long, then yes, you could tune a query to do it, but that doesn't sound like it's a situation here. If they had asked a different question, if they had asked about tuning the queries, but it sounds very much like this is a pretty simple situation where it's like the query's not going to get any faster. We're taking that lock and holding it for other reasons. So I agree. There might be a time when if the lock was being held on for too long because the query was long running, that's one thing, but it doesn't sound like that's it. Yeah, exactly. Some type of queuing. All right, so let's talk a little bit about memory. We've got indexes cleared out here, and I've got this store procedure. Now, the guts of this store procedure, this store procedure does not take any parameters, and I don't want it to take any parameters because that would ruin the fun. People would get all caught up talking about parameters, and parameters have nothing to do with this. Now, we're going to do a couple things. Let me crack open. Oh, yeah. Every time I do this, SQL Server, Windows is like, I don't know where RML utilities are. I can't find RML utilities. But meanwhile, if I go right here, I can find the RML command prompt, and everything is fine. It's like I'm being messed with. I'm being messed with constantly. If I say RML, like, oh, I can't find it. But it's right there. Stop being stupid, Windows. Like every time I do this, I'm like, why not Linux? Windows is such a dummy. Such a dummy. I can't take it. Can't take it some days. But I've got this store procedure, and the guts of the store procedure run this kind of big, goofy-looking query. And what I want to do is stick this into a new window. This is my store procedure SP pressure detector, and I believe everything's spelled right, and it should run. Good stuff. But what this does is two very specific things. It is not meant to compete with SP Who is Active or any of the Blitz scripts. It is sort of its own thing, and you can choose to run one of two queries or both. All right, so what you can choose to do is either look at memory pressure, or like things that might cause memory pressure, or things that might cause CPU pressure. We'll do both here, but first we're going to look at memory. So what this gives you back when you look at memory is if we had any queries running that were asking for memory, they would show up in this top space. If we had any queries that were, sorry, if we had any queries that were asking for memory, we would see some of the numbers down here start to change a little bit. We can see that looking at some of these numbers going across, SQL Server says right now, I am willing to give out just about 38 gigs of the 50 gigs max server memory I have. This is a VM with 64 gigs of memory. I'm willing to give out just about 38 gigs of memory right now to queries that might need it for memory grants. Okay, fair enough, SQL Server. Fair enough. Let's see, just to keep up with chat, it's already RCSI. So if it's already RCSI and you have queries taking row locks and they're kind of getting held onto there, I would also expect to see other locking hands, like maybe a hold lock or something in there, so that things are kind of held onto, but I'm not sure, and I don't know. Yeah. Fun stuff. But we can see right now, but we haven't given any out, right? So SQL Server is like, I would give out about 38 gigs. I haven't given any out now. Nothing's going on. That's totally cool. If I go and run this query, and all I need is the guts of the stored procedure, I don't need to execute the entire stored procedure. But if I go and run that, and I look at what SQL Server does, I don't need this to keep running. We'll let that die gracefully since I just executed it. We can see that this query has asked for about 9.4 gigs of memory. That's 9,474 megs of memory, which is just about 9.5 gigs, right? That's a lot, right? That's a lot. Now, ideally, or rather, what we see down here is where SQL Server has taken as total memory, or rather, available memory. There we go. Available memory is now down to 28 because we have granted out 9.4 gigs, right? So the total memory now is still the same. Total memory is like, we'll still give out about 38 gigs, but we have much less of it available because we gave some out. Now, I don't know if any of you are good at math. I'm not good at math, but I'm going to tell you what happens if we try to run a bunch of copies of this query all at once. So I'm going to use this. I'm going to use the OStress utility, or rather the OStress program from RML Utilities. If you want RML Utilities, you can go over here and get them. It is a pretty neat, spiffy, fun tool. I like it. I also like SQL Query Stress, but SQL Query Stress kind of crashes a lot sometimes, especially if you ask it to use a lot of threads. So just kind of for safety, I like to use OStress. Narav says, let me guess, bad things happen. Yes, indeedy doody. So what I'm going to do is I'm going to run 4 copies of this store procedure all at once. We'll get that going over here. Yep, no whammies. Excellent. Come over here, run this. And while that happens, I'm going to kill this off because I don't want my laptop to get too angry with me. So we have the information we need. We don't need any more information right now. So what we have is 3 copies of this query that run pretty well. Or rather, they run. SQL Server gives them the memory that they need, or that they ask for. Whether they need it or not is completely besides the point. But SQL Server is just like, yeah, for these 3, go ahead. You can take it. That's all you. You can have it. I don't mind. But you, session ID 57, you get nothing. The grant time down here is null. The granted memory is null, right? It is still asked for it's about 9.5 gigs of memory, but it hasn't gotten it. Right now, this query is off waiting in a queue to get memory so that it can start running. While it waits in this queue, you will generate this very, very silly wait up here. Remember I said all the queries that have gotten their memory grant and are off doing things have CX packet waits. But our poor query down here that has not gotten memory, that is waiting for memory, is getting these resource semaphore waits. Notice it doesn't have any workers, it hasn't done anything. We have a query plan for it. That's not really the point. But what we don't have is enough memory for this query to run, which is kind of funny. Because if we look at how much memory this thing has asked for, that's exactly how much memory we have left to give. Right? So we have 9474.75, lots of zeros left, and we have this query asking for it, but it's not getting it. It's not getting it because our query would need 9.5 plus half of 9.5 in order to run. Right? So you need to have, not only when a query wants to run that's asking for a memory grant, the available memory not only has to cover that memory grant, but also another half, so that if anything else comes along, it needs a memory grant. SQL Server can be like, yes, you can have that memory. Well, this thing waits because it is terrible. So yeah, this is not a good situation, and you can run into this when you have either something like this where you have a few queries that ask for very big memory grants, or you have lots of queries that ask for kind of smaller memory grants, and they all sort of add and stack up. Now, very simply, this is 3 queries that have asked for about 28.5 gigs of memory. You could totally write a query that wanted like 1 or 2 gigs of memory and run like 14 or 15 of them and have the same hell break loose. It doesn't matter. All those memory grants have to come from the same place. Query memory grants come from, typically, there are of course a couple few outliers, nothing that I think is so constant that you need to be concerned about it. But query memory grants typically come from 2 places or 2 specific operators in a query plan. They come from sorts and they come from hashes. This query has a little bit of both in them. Right? We have a hash join up here, and we have a sort right about here. The thing is, hashes, when you see a hash, they typically build a hash table based on whatever input goes in. The hash table over here isn't all that gigantic, right? It's only for a couple million rows, and if we, I forget if this is going to be completely accurate. If you look at the memory fractions here, the closer you get to the number 1, the higher the fraction of memory you get is. So this hash join actually got a very, very small amount of memory. Or rather, got a very, very small amount of the 9.4, just about 9.5 gig grant that SQL Server gave to this query. The majority of the memory will, and in most cases, will always go to sorts. Sorts can really just ask for a size of data as far as memory goes. It's pretty crazy what sorts can ask for. If you look at the memory fractions for this sort, this memory fraction is very, very close to 1. So you can see that the sort got almost all of the memory. Now, operators in query plans can reuse memory. Like if they finish, they can pass memory along. That's why memory fractions are often kind of weird and don't always line up perfectly. It's because memory might get reused and shuffled along, but it's a little bit more complicated than I want to cover here, because this is, after all, about indexes. This is not about memory, of course. So some stuff to keep in mind. Now, let's go look at before I close out, let's look at what was sorting. We have an order by on user ID ascending and score descending. And we have an output list that is just about every other column in the comments table. Most of these columns are harmless. And by harmless, I mean they are numbers and they are dates. Dates and numbers don't really have a big memory footprint. Now, you might have a very, very long data set. Right? And when you have a very, very long data set, sure, you might have a bigger memory grant because you have more things to sort. But what really, really starts to chew into memory grants and get SQL Server to really inflate memory grants are going to be string columns. This column is called text. It's not a text data type or an ntext data type. I want to say it's an VarChar 700. So it's not even gigantic. But the way that the optimizer guesses memory grants, or how much memory it will need when we have to... Now I'm going to show you something important in a second, so don't get too carried away. But whenever you need to sort text columns, remember we're ordering by user ID and score. We're not ordering by the text column, but the text column is part of the result set. So what we need to do is we need to write user ID and score down in order, in the order that we're asking for. But all these columns that accompany user ID and score, I mean aside from user ID and score, so like ID, creation date, post ID, and text, we have to write those down in the order that we sort user ID and score in. SQL Server will estimate for string columns that every row is half full. So let's just, to make it very simple, let's say you have a VarChar 100 column. SQL Server will estimate that every single row for that VarChar 100 column has 50 bytes in it, meaning that it's half full. That gives it some fudge factor. If some are very full and some are not that full, then we kind of meet in the middle and you probably have a proper memory grant. the bigger your columns are, regardless of how full they are, all the way up to max data types, which will ask for a big honking memory grant. The wider your columns are, the wider your string columns are. So if this was like an VarChar 1400 or 38400 or 2800 or whatever numbers add up, SQL Server would assume that column is half full and ask for more and more memory. That sucks. That's not good. That's not a good situation. So whenever people have those big long presentations about right sizing data types and no, don't use date time if you only need a date, and don't use a big int if you only need an int. Sure. Knock your socks off. What I care the most about are those string columns, because people will always get carried away and they say, I have no idea how much data can get in there. I better make it a max. And whenever they do that, the next thing I see is queries like this that start asking for 9.4 gigs of memory to sort that text column by a couple other columns. Now, what the query itself is doing over here, right? If we go and we look at what that query is actually doing, right? We don't have an order by here, and we don't have an order by here. What we have is a windowing function. And this windowing function is partitioning by user ID. So that was the first, remember, when we looked at the execution plan, it was order by user ID, then order by score descending. So we're partitioning by user ID, which means we have to, you can almost think of partition by like group by without a grouping. What it does is SQL Server just looks at the results, and every time it gets to for every bunch of duplicates, we'll say this is like group 1, this is partition 1. We find another group of duplicates, that's partition 2. We find like a single row that's a new one, we'll say that's partition 3, and so on. Let's see, Narav says it's worse when people use char versus varchar. Yeah, so for char it assumes complete fullness. Well, char is different because it is completely full anyway. Right, so for char, if you have a column that's char 100 and you only have like 3 or 4 characters full in it, the other 96, 97 characters is going to be just padded. Right, it's going to be like that anti-padding stupid setting or whatever. So yeah, it can totally get weird in there. But char is worse, and varchar is of course worse because it's Unicode and it's double byte encoded. So if you had in varchar 100, SQL Server would count it as a would of course multiply it by 2, so you get a 100 byte guess there. Would a PLC index help here? Yes, but you are jumping the gun, Lee. Damn it. You're banned from all my future webcasts. But yeah, so what we have here is a row number function on user ID and score descending. And since we're selecting a bunch of other columns, SQL Server needs to write down all of these other columns in order. I'm not a huge fan of Excel. I'm also not a huge fan of comparing SQL Server to Excel, but I think explaining it like an Excel file is a lot more relatable to people. Let's say you crack open an Excel file, and it's full of data going across, and you click that little button up in the top left-hand corner that highlights all the rows and columns, and then you choose to sort data by one column. The entire spreadsheet will flip to match the order of that column. And that's a lot like what order by does in a query. You don't just order that column that you're saying order by. You have to order the entire result set for that column. So you're not just sorting that one column in memory. You're sorting that one column in memory plus all the columns you're selecting. If there's bandwidth issues, I don't know. Sometimes. No, it happens sometimes. Sorry about that. There is relatively little I can do. All I can do is wait for my streaming service to catch up. I apologize. These things happen. Going live is crazy. If you know what I'll do though, I'll wait a second until people say that things have calmed down, and then I'll pick back up. Yeah, this happened a little bit yesterday too. It was back at the beginning of the stream when it happened. Today it's happening at the end of the stream for some reason. I don't know. I guess I'm just lucky. Perils of live broadcasting. So we've got this query here, and really what's asking for the memory is this part of the query where we're generating a row number where we're saying partition by and order by. Looks good now. Sweet. Let's get back to business then. So what we're going to do is we're going to create this index, and this index is going to help our windowing function do its work. So we're going to have user ID as the first column, because when you looked at the sort operator, user ID was sorted by first ascending. Then we're going to put score descending as the second key column. So our index will be ordered by user ID and then score descending, which is a great index for this query. And since I have relatively little caring for what's going on this thing, because it's all just a funny dev server to me, I'm going to include all of the other columns that we need in here in order to cover the query entirely. Because remember, we're selecting basically everything in the table, and then we're having this row number generate over these doodads, right? So this is I don't know, is this an index that I would create in production? If this query was important enough, sure, but I'd also might be a little nervous about it. But what's cool now is if I go back to RML utilities, and I'll clear the screen, and I'm going to rerun this. If we come back over here now and we look at SP pressure detector, well, nothing's happening. We haven't given out any memory, right? There's no memory given out, and there's no memory granted out here. We have granted out a big whopping goose egg. No queries are showing up. No queries are showing up here because no queries are asking for memory grants. This specifically will check for queries that are asking for memory grants. One way we can see what's going on is if we rerun that and we go look at SP who is active. This will show us what's running. Like, oh, I should probably not have query plans on for SP who is active, should I? Whoa, that would be scary. But if we look over here, we'll see 4 queries running. Those are our 4 queries that we care about. And if we look across, we can see that they have used very, very little memory. That's like what? Not much. That's a 4. That's nothing at all. And if we go and look at, did I get the execution plan? I didn't. Let's go get the execution plan from over here. That sounds like a good idea to me. So if we run this query and we get the full execution plan, this should finish in about 6 or 7 seconds. If it doesn't, then I owe you all a drink the next time I see you. Whatever you drink, it doesn't matter. I hope you like water. Okay, I lied. It's probably about double that. Okay, I lied. It might be triple that. Okay, I lied. It's returned a lot of rows, okay? It didn't actually take 19 seconds. It took about 7.5 seconds up here. All right, good for us. 7.4 seconds. Okay, close enough. Close enough. But notice that we don't have a sort operator down here. We no longer have to sort data, and we no longer have a hash join. We have a merge join, since everything is in the order that we want it in, which is lovely too. I like that. Is this a perfectly tuned great query? Well, you know, it runs 7.5 seconds. It returns a crap load of rows. Like we might want to do something about this eventually, because this runs for 19 seconds. Like most of that time is returning 3 million rows to stupid SSMS, and the query finishes in 7.5. But what's important is that if we go and we look at the properties, if we look at the memory grant info, this query isn't asking for any additional memory. Every query that runs in the world is going to need some memory. It's going to need a little bit of stuff for like operator state and other things, but it's not going to ask for an additional memory grant. That other query, or rather this query, that other query plan, which was this query without the index, went and asked for 9.5 gigs of memory. This one's not asking for that extra memory grant, but you still always need a little bit of something to have the query run, because memory is pretty essential for everything. So we have that query asking for a little bit of memory, but we don't have it asking for the big grant. Now, sorts are one of those things that can ask for crazy, crazy amounts of memory. I'm not saying you always have to index to fix them, but what I am saying is you should, if you have queries that are asking for large memory grants, sorts are probably the first thing that I would look at before hash joins or hash aggregates. I'm not saying to rule them out entirely. I would just usually focus on the sorts first. Look at the columns we're selecting. Look at what we're ordering by. And sorts don't only happen with windowing functions or just putting an order by in there. Sometimes you might put a select distinct in there, and SQL will choose to order by all sorts of things. Sometimes SQL Server might choose to implement a merge join or a stream aggregate where we don't have the data in the order we want, and it'll choose to sort that data going into those operators. Even sometimes for key lookups, it'll reorder data going in. So there's all sorts of reasons why you might see a sort in an execution plan that have nothing to do with the way you writing the query with an order by or something in it. That might not ever show up, but there are all sorts of things in databases that ordered data is helpful for. All right. I don't think there's any questions on that. Hopefully everyone is still alive. I guess it looks like a few people left when things got choppy. Thanks for braving the storm with me. It's not nice. Make me feel bad now. All right. Anyway, let's go look at one last kind of fun, interesting thing. Let's go look at how SQL Server, or rather how we can deal with another awful, crappy, crazy kind of weight that has to do with threads. Would you ever create an index with descending? Yeah, sure. I created one up here with that was descending. Score descending. It's a funny trick. So sort of generally, there is a very funny thing in SQL Server where backwards scans of indexes can't be parallelized. And sometimes if you see like something that looks kind of funny, let's say you have a query plan that is like 99% parallel, but you have like one big index scan that for some reason is serial, and then like right afterwards is a distribute streams or a repartition streams. And you see that, you might want to again look at the properties of the operator. You can look at the properties by either, I don't think I have a query plan open right now, but let's just grab this, get an estimated plan. If you either right click and get properties or hit F4, you can see the scan direction in the query plan operators. It doesn't show up in the tooltip. It doesn't show up in the tooltip. It only shows up in the properties. But if you look at this scan direction and it ever says backwards, and you have a mostly parallel plan except for this one thing that's serial, then what you're doing is you're scanning the index in a backwards order, and that cannot be parallelized right now in SQL Server. It's supposed to have been done for 10 years or something, but just no one's ever done it. So yeah, it's something that I would do. In certain circumstances, but and a lot of times it has sort of limited usage. So that's fun. Let's see. SQL Server licensing. Oh, God. I don't want to talk about that. Do you have any idea what that's like? That would only be valid for 6 months. Would not be could not be useful in a year from now. No one would care about it. It would be awful. And I would get sued. I would get sued so much. I would get sued constantly. It's like, I heard Eric Darling say that we only need a license, blah, blah, blah. And then I would say, oh boy. Sorry about your audit. I'm sorry about the state of that. All right, so let's move on a little bit now, and let's talk about how SQL Server can... let's look at a crazy situation with a different kind of crappy weight. And this one's going to be all about threads. Now, if I run this query actually finishes relatively quickly. It's a relatively quick query, thankfully. I'm happy with how fast this query is. It's good that it's fast, right? We like fast queries, but regardless of how fast this query is, this query does something kind of crappy. So let's go look at properties over here, and let's go look at thread stat. So this is something that I'm going to say new. But by new, I mean this came out in SQL Server 2012. Let's see. Stefano says, I reckon one can scan through the execution plan. Yes. So actually, there's a check in SP Blitzcache under expert mode that I wrote that will find backward scans. That does show up in there, and that is something that you can look for. But it's under expert mode because the number of times that I've found it being the root cause of a performance problem have been pretty slim. I'm not saying that it's something that you never want to look at, and I'm not saying that it's not something Microsoft should fix. Listen, Microsoft shouldn't fix it, but at the same time, very rarely have I been aha, it was the backward scan that did it. We fixed the problem. It's always been there's 1,000 things wrong here. The backward scan was just one of many. And usually if you if you just create an index that is like most of the way to being helpful, then the backward scan just becomes less of an issue. So just my experience. I'm sure someone out there can show you where a backward scan has been like the most awful red-headed culprit for query performance, but it hasn't been my experience that has often been the root cause of an issue. But yeah, Blitzcache will find it if you run expert mode, and it happens to pick up on a query where that happens. So parallel queries are kind of funny. Parallel queries, or rather queries in general, will, if you join tables together, or if there's a key lookup, you'll have these branches. All right, so by branches, I mean this is like one branch, and then down here, this is another branch. And if we scroll over to the left a little bit, you'll see another branch that sort of diverges off that main path there. And so when people talk about parallelism settings, when people talk about max stop and cost threshold for parallelism is pretty easy to explain. If you hover over the select operator and we zoom in a little bit, we can see that the estimated subtree cost for this query is 860 query bucks. And so this was a fairly expensive query. At least it was expensive enough for SQL Server to, so this is where things get even funnier. This parallel query cost 860 query bucks. SQL Server chose this parallel query because it was cheaper than the serial query. If we just, let's just, for some fun and giggles, let's just stick an option max stop 1 here. And let's just get an estimated plan real quick. If we look at how much the serial query cost, it's 991 query bucks. A lot of people will look at parallel plans and say, I don't get it. Why is the parallel plan less than cost threshold for parallelism? It's because the parallel plan doesn't have to be worse than cost threshold for parallelism. The serial version of an execution plan that the optimizer comes up with first, that's what has to be higher than cost threshold for parallelism. So at 990 query bucks, that's way higher than what I have it set to on my server, which is like 50 query bucks. Now, if we go look at the parallel version of the plan, all right, we'll go run this real quick again. We'll get rid of that hint, and we'll rerun this. If we go look at the parallel version, which cost 860 query bucks, that is about 130 query bucks cheaper. So that's why SQL Server chose a parallel plan here. Totally fine, totally pretty easy thing to explain to people. Max stop is where things get a little bit trickier. A lot of people will say, well, it limits the number of cores that a parallel query can use, which is mostly true. Like some of my friends might yell at you that it actually limits the number of schedulers that a query can use, which is apparently different from CPUs in a way that I have never been able to expunge on them. As much as I try to ring these smart people out for details, they'll never budge on it. But what MaxStop also controls, aside from the number of schedulers that you can use, is the number of threads that each concurrent parallel branch can use. And I know that sounds tricky, and it is. So in this query, there are indeed 3 branches off here. There's a little bit more technical detail behind what defines a branch. It's really the space between any 2 parallel exchanges. So over here we have a repartition streams, and down here we have a repartition streams, and over here we have another repartition streams. So technically this is one branch, right? Technically these operators between a repartition streams are a branch. Ditto some of these over here. Like when we go past that repartition streams, we might call all the operators between the gather streams and the repartition streams another branch, which would be all of these operators. Now there's a repartition streams down here too, so things just get all sorts of weird. But this query has 3 branches that could run concurrently. You might see parallel queries that have many, many more branches than show up down here. What branches measures here is not the total number of branches, but the total number of branches that could possibly be running at the same time, that could be running concurrently. There are again, going back to memory consuming operators, hashes and sorts, those are also what we call stop and go operators, which means all the rows that they need to process need to show up there before they can start running. That's one thing that can sort of separate which branches can run concurrently. In this query plan, aside from the fact that we have repartition streams operators that define branches, we have hash joins, like this one right here. Right, there's a hash join right here, which means that all the rows from this part of the branch have to show up here so we can build the hash table. All those rows have to show up, and then once that starts kicking off, this can start running. While that's running, and rows start coming out of here and passing through the hash join here, then all sorts of stuff can happen in here, up into the point where we need to start building another hash table here. And then once that hash table is built and we start probing in down here, all the rows that start passing out from down here can start coming out up here. So at any given time, we can have 3 concurrent parallel branches. And that gets borne out when we look at the thread stat properties of this plan. Now I have max DOP set to 4. So my degree of parallelism for this is 4. The number of threads that this branch uses is 12. I want to say the reservation matches here. It does. So we've reserved and used 12 threads. So we have DOP 4, right? We have max degree of parallelism set to 4, so we can use 4 schedulers to run this query. But we can use 4 threads per branch for this query, meaning altogether this query will reserve and hopefully use all 12 threads. Right, 3 times 4. You got it. I just like to explain it the long way, because a lot of people, if I just said 3 times 4, they would say, huh? But yeah, 3 times 4 is 12, so we have 12 used threads, 12 reserved threads, and we have 3 parallel branches for a DOP 4 query. So I promise you, it doesn't add up, does it? It all multiplies up. Good that it multiplies up. But, and this is where things get tough, if we look at the number of schedulers, the number of worker threads that I just like saying schedulers, but if we look at the number of worker threads that my server has, it's 576 total. Now, this is a Microsoft supplied algorithm. If we take 512 plus the count of schedulers that are visible online, minus 4, times 16, that is how many worker threads you have on your server, unless someone has messed with the max worker thread setting. That is the way it will happen. I want to say things change a little bit beyond from 64 cores and up, but this is what we have. And what's terrible is that it's shockingly easy to run out of CPU of worker threads. So what I'm going to do is, and I'm going to hope that this works, because it worked last time, is I'm going to change the connection here, and I'm going to use the admin connection, and it's going to say that it failed, which is okay, but I'm using the remote DAC right now. But you can tell that I am because I have this admin connection down here. And the reason that I'm using this is because when I do this CPU demo, and I start to run out of worker threads, it becomes very, very difficult to connect to the server and even run simple DMV queries. So you can see I have 576 threads. Right now, SQL Server in the background, just for whatever, is using 28 threads for other things, right? What things, I don't know. They might be bad. They might be good. I really don't know. Now what I'm going to do is go back to OStress, and I'm going to run a whole crap load of copies of this query that take 12 worker threads. I'm going to exacerbate the situation. Sure, I could try to play with it so we got like the exact number and took out the exact blah blah blah. But I just really like to kick the crap out of it here so people understand what things will look like when everything kind of goes south on them. So I'm going to run this, and we're going to immediately have exactly what I want. I'm going to run this one more time for good luck, and then I'm going to kill this off. So SP pressure detector, we've changed this to be from memory to look at CPU. We've connected via the remote DAC so that we don't get thread pooled out of running these queries. But this is what happens. We had a whole bunch of copies of this query running, taking 12 worker threads for each, well, I want to say taking 12 worker threads for each copy. That's not going to totally be true, and I'll show you what I mean in a minute. But if you look at what happened here, we have 576 total threads. We've used 612, which gives us a grand total of negative 36 threads. We have 221 threads waiting for a CPU and 96 requests waiting for threads. Those 96 requests are all going to be in this section. If we look down here, we'll see that for the section of queries, or for that section, we have 96 rows, right? So that's the 96 requests waiting for threads. Requests waiting for threads is where we have thread pool waits. If we look in here, this is where we're going to see those 96 rows. Now, where things get very, very tricky and very, very ugly is when you have a script that goes to show you what's currently running on your server. What's the first thing it's going to do? It's going to join in some order DM exec requests to DM exec sessions, and it's going to join them together on session ID. The problem with that is that if it's an inner join, you're not going to see any of this because this session ID column is completely null. There is no data, there is no session ID in here to join those tables together on. When SQL Server runs out of worker threads, we can't even give queries a SPID to run on. That's how completely out of CPU resources we are. We are completely shot. When I ran this the second time, queries had been waiting nearly 6.5 seconds to get worker threads to execute. All right, and if we scroll down this list, we're going to see all 96 queries. This one was waiting almost 3 seconds, but from almost 3 seconds up to about 6.5 seconds just to get threads to run. If we weren't connected via the DAC and I tried to run this query, it would time out, SSMS would throw an error message, and we would say, I don't know, server's down, restart it. We would restart it, and things would probably go back to normal. But that's no fun. Right? That's no fun. I like to give you the information that you would get if you had listened to me about setting your server up right, and you had enabled the remote DAC. That's all I want. Now, the third set of results from SP Pressure Detector is going to give you CPU intensive queries. Now, these are all queries that at least do they all have session IDs? I forget. Yeah, these queries all have session IDs. So this is 243 rows. So these 243 queries all got SPIDs and were all able to start running. But there is a big but here, and this is the kind of big but that Sir Mix-a-Lot does not care for. If we go over here and look at what happened to some of these queries, we'll see that very many of them are running at DOP 4 and have reserved those 12 worker threads that we talked about. But if we start scrolling down a little bit, we will eventually see that change. What happened? DOP is 2 here, and we have 6 worker threads. DOP is 1 here, and this is going to be null for the worker thread count because we can generally infer enough that a DOP 1 query is only going to need 1 worker thread. we can do that. But what's super sucky, crappy, just plain mean is that SQL Server won't tell us that these queries were actually running at DOP 1. So what we have here, I'm going to bring only the DOP 1 queries into the screen. Right? This is all DOP 1, and if we go all the way across to where the query plans are, did I go too far? Not far enough. There we go. So these queries were all running at DOP 1, but the query plan that we see from them is going to tell us that it's running in parallel. So SQL Server, when you start running out of worker threads, one thing that SQL Server will do is start downgrading DOP for your parallel queries. Right? Remember, we have this one query up here that was running at DOP 2, and then all of a sudden it drops off to DOP 1. So SQL Server, the first thing it will do is say, parallel queries, sorry, I don't have room for you. We're going to run you at DOP 1. If you don't like it, talk to the person who bought the CPUs, or talk to the person who tunes the queries. You know, I can't do anything for you. No room at the inn. But we'll see that a whole lot of these were actually running at DOP1. So SQL Server actually did a lot to try and avoid running out of worker threads. But in the end of the day, we just completely overwhelmed it with queries. And we had 96 of them that just couldn't even get a worker thread. When you can't get a worker thread, you end up showing this thread pool weight. We've looked at two pretty terrible weights today. We looked at resource semaphore, and we've looked at worker threads, or thread pool rather. If you see a lot of these weights on your server is in tough shape. Lee says, is there a way to set that threshold where it starts limiting threads? No, I don't think that's something you can set even in Resource Governor. I think that's just something that SQL Server fires off internally at some threshold. I'm not sure what it is or where. There might be a weird trace flag for it. I don't know. I wish I knew. I wish I was that smart. But yeah, I don't know. But no, I don't think there is a way to do that. I think that's like a judgment call from SQL Server. You know, it's like at what point does the pain here mean you call 911? I don't know. So I'm sure that threshold is different for different circumstances and different people, but pretty cool there. But of course, the main thing with this query is, like, if we think about what that query is doing, right? If we this query runs pretty quickly, and it's parallel, but if we throw enough copies of it out there, it'll suck. But if we go look at the query, we're joining stuff together. We have a where clause on reputation, but at the same time, we don't really have indexes that support this query very well. Lee says, I would be more conservative than SQL. Well, I don't know if that's easy. In some regards, it's easy. In some regards, that's hard. It's a hard decision to make. But really, the problem here is that we just don't have very good indexes to support this query that we're running. So let's create some indexes. Because remember, the whole point of this session is about problems you can fix with indexes. And this is another problem that you can pretty reliably fix with indexes. Because with the right indexes in place to help queries find data and join things together and sort of get things done in the right way, we can end up with a query that runs pretty quickly and doesn't need to go parallel. Right? So this thing finishes in 849 milliseconds. There's no parallelism going on here, which means that we are running at DOP1, which means that we could run 500 copies of this without SQL Server really, go and crap things out. Let's see. Ronald says, can a sleeping session still use a lot of CPU? So the way that the DMVs work is that they just tally things up, right? They just tally things up as things run. So a really awesome thing to do, if you have queries that are sleeping, that have a high amount of CPU, is you can do exec sp who is active, and you can do at I want to say it's delta interval equals 5. I might be wrong about the delta interval. No, I'm right. So, and what this will do is it will look at how much progress. I'll put that into chat. It'll look at how much progress or how much resources your query has used over a span of time, right? So for this one, I ran it for 5 seconds. So what SP who is active will do is it'll go through and do like the initial run of SP who is active. It'll wait 5 seconds. Like if you've ever used SP Blitz first and done like the second sample, it's totally like it's almost the same thing except for who is active. And what it will do is it will go through and it will add these columns in called delta. And these delta columns will tell you how much resources that query has used over a span of time. So if you have a sleeping session, and that sleeping session has a high amount of CPU, run who is active with a delta interval and see if it's still accumulating CPU. If a session is asleep, that usually means that the query has finished and either the application has forgot to close it or some weird connection pooling thing is happening. Maybe there's a leak, but the connection hasn't closed. So typically a sleeping session isn't going to keep accumulating resource usage if it's been sleeping for a long time. Usually something has to be like running or runnable in order to get more stuff. Let's see. Wes says, can't I just tell my director that I need more resources and ignore all this? Yes, up to a point. But it depends on where the budget for more resources comes from. So if the budget for more resources comes from your bonus or your paycheck, I might want to fix the problem. Right? Max stop 1 is the ultimate solution. Yes, if you want everything to be terrible. Right? You want everything to be terrible. Max stop 1 is a good solution. I like parallelism. I love parallelism. It's one of my favorite things. Okay, let's see here. What else do I have left? I think that's it. Is that the end? That is the end. Wow, that's the end. Good for us. So, what did we learn? All sorts of ways to fix problems with indexes. We looked at how to solve performance problems, how to fix spools, how to fix blocking, and how to fix queries that just use way too many resources. I think it's a pretty good run. It's been almost 2 hours since I started, so I'm going to stick around for another like 5 or so minutes, right until the top of the hour. If you have any more questions, comments, anything like that, stick around for that. But other than that, I could use. I'm starting to get this, so I could use some liquid, and I could use. I don't know. I would like to sit down again. To be honest with you, but if you have any other questions, anything else you want to ask about, I know there was someone on earlier who asked for a copy of the script. I'll put that up in the resources either on Twitch or on YouTube. I have to make sure that I have the most recent version of everything all zipped up, and then I'll get that out there. Let's see. Tell your director that, then fix the issue. You'll be swimming in resources. Yeah. And then what you could do after that too is you could tell the director that you fixed the problem and give a bunch of resources back and say, look at all the money I saved you. Give me a raise. This is something that people love doing during pandemics. Says, this is great. Your streams are top notch. Thank you. I hope I can keep I hope that I can keep up the top notchness. I'm thinking about bringing back the office hoursy type thing, because that seems I don't think anyone or really anyone's doing that either on Twitch or YouTube or anywhere right now. So maybe I'll start doing something like that once a week again. I don't know. Yeah, I'll get the scripts out as soon as I can. I'm gonna go faint for like 20 minutes when I'm done, and then I'll come back and I'll get the scripts ready. All right, I'll start doing them again. It was tough. It was tough last time around. I know it was only on YouTube, and the setup was rather unsophisticated, and the schedule got tough because once like client work really picked up, I couldn't always do the Friday thing. So well, Mr. P. Shaw, I will pick it back up. If you come to me day 1 for a 64 core box, you buy it, and day 2 you say, by the way, I tuned the code, we can run on 4 cores. I'm not going to be smiling. Yeah, I guess, but just think of all the room to grow you'll have. Think about the upward expansion that you have there. Think about that. You have 60 cores that you can grow into. Oh yeah, I know it's so tough. Sometimes services get one service is blocked, another one doesn't. If I do it, I'm gonna do it just like these, and it's gonna be YouTube and Twitch. I don't really have any other places to stream things out to. So if anyone has like suggestions for other services that I can stream to, that would be it. Ginarfrey says, I have simple queries running 10,000 times an hour. How do I fix this? That is something you can really only fix with developers. Mixer, I don't know. I've never heard of Mixer. I'm old, but I'll look into it. But that is really something that only developers can fix, because things that are running that frequently they're not running that well. Okay, I'm going to take that back. I'm going to walk that back a little bit in a minute. But if you have queries running that frequently from the application, then that's something that developers would have to fix, either by not I'll say something obvious, not running those queries so much, or having those queries hit like some caching layer and only refreshing the cache for those queries less frequently. The other times that I see simple queries running constantly like that is when you have scalar valued functions or multi-statement table valued functions that are called in queries that return lots and lots of rows. Because one kind of hidden issue with with functions like that is that they don't run once per query. They run once per row returned by the query. So that they can really sort of they can really run quite frequently if you call them inquiries that return or process lots of rows. It could also be like neuropsis. It could also be like cursors or something that could fix. But there's no like no button you can push in SQL Server that says you're only allowed to run 100 times an hour. I wish there was, but might be dangerous. If only SQL Server had a caching layer. I guess I don't know. I don't want that. If anyone from Microsoft is listening or watching, I don't actually want that. But yeah, that is typically a developer problem. That's typically not something that a DBA can fix or limit on their own, unless it's happening from functions. What I would say is if you want like sort of a decent way to, oops, I did that all wonky. You want a decent way to track that down. Ah, my God, I can't type today. This is why I type everything ahead of time, because I can't type, especially when people are watching. If we do SP Blitz Cache and we do sort order equals XPM, XPM stands for executions per minute, and what we can catch with executions per minute is stuff that executes quite frequently, and it just might be a sort of easy way to catch high frequency execution things. So unfortunately, I don't have anything all that interesting in here now. We could also just do plain executions and run that. And this would sort the plan cache by executions. And this is another way to kind of find things that execute frequently but just may not use a ton of resources. So like this has executed 243 times. Executions per minute isn't something that the plan cache directly tracks. It's something that Blitz Cache tracks by looking at the number of minutes between when the plan was created and last executed, and then doing some division to see how many times it was executed in those minutes. So it's coming up as 0 here because of how fast those 243 executions happened, but generally using either XPM or executions, you can catch what's happening. If they are functions, then they might be things that you could rewrite and fix. But if they are just pure, like, I don't know, like entity ORM queries, something like that coming in, then it's not anything you can do. Cryron says, when we use max.8 and index, how is the index structure? I only use it so the index creates a little bit faster. There's really nothing about the way the index is structured that it changes or helps. At least for row store indexes. For column store indexes, DOP can affect compression, and typically the lower DOP is, the better compression you get, or rather the few open like row groups or whatever you can have. But for row store indexes, I only do it here. I really only do it here during demos so that the indexes create a little bit faster. It's really not anything like, it's really not any special magic like, God mode ID clip, contra code thing to get extra index lives or anything like that. All right. I'll give it another minute. Any other questions? Anyone else want to talk about anything? This went on longer than I thought it would. I didn't realize I had so much to say until I started talking. And then I just kind of went off the rails. Bum. And now I have nothing. Now I'm just brain dead and have nothing to say, which is probably nice. Like, some people probably are grateful that I'm brain dead and have nothing to say. All right. Anyway, thanks for showing up. Thanks for hanging out. Thanks for watching. If you have not already done it, and you are the type of person who enjoys SQL Server content, if you follow me on Twitch, or as the kids say, like and subscribe over on YouTube, you'll get notified whenever I start doing one of these things. If you follow me on Twitter, you'll also get that. But it's always nice to have a good crowd in here to do things. I like having lots of people, lots of questions, lots of different levels of experience. So come on back. Tell a friend, invite, whatever it is. I forget how all this stuff works. But please follow along. I'm going to be doing a lot more of these now that I'm kind of set up to do it, and I have all sorts of fun things on my mind, then I hope that you find it useful and entertaining and enjoyable, and I will see you, I don't know, maybe I'll even come back tomorrow and do something. But thanks for showing up, thanks for hanging out, and I will see you next time. Adios.